Hi, my name is Bob, and this is my homemade pinball machine. It was made using components bought at the home store, along with commercially available pinball parts, along with an Arduino board which is used to control the gameplay itself. If you've ever wondered how a pinball machine works, or are interested in building your own pinball machine, then stay tuned. Before we go any further, let me prove to you that this pinball machine plays like a real commercial unit. Okay, so I'm not very good at playing pinball, but you get the idea that basically this is more or less like a commercial unit, and therefore that's what we're going to be showing you is how commercial units are done. This unit itself, however, is a bit simpler than what most commercial units are, but it's still a very challenging game to play, and obviously, if you decide to make your own, you can make it as complicated or as simple as you like. Let's first talk about the case. The case itself is made out of oak-faced plywood. The top is made out of oak in a picture frame kind of style. Instead of glass, I've used plexiglass because it's lighter and easier to cut and deal with. You notice that the case is on an angle. This is controlled by the legs, which are basically commercial legs that I bought that screw into the bottom of the base. The bottom of the cabinet does have a shelf in it that allows me to put things like the power supply and other components in it. Out of the back of the cabinet you can see some power strip that's been attached to the back. I also have wire coming out of there that's a USB wire that can be used to connect to the Arduino board, so I don't have to open up and disconnect it or take apart the board in order to connect to the Arduino board. You'll notice that there is no back to this cabinet. That's obviously very unusual for a pinball machine. Most of them do have a back. If what you saw before looked like a back, what it actually was a picture from a piece of glass from a pinball machine that I've mounted on the wall and have used some Christmas tree lights in order to light it up. You'll also notice there are some lights that are under the rim of the frame itself, and those are LED lights that flash through a variety of different colors. Again, those were available at the home store. The pinball machine is fairly simple in design. There are a number of different components. There are rollover lanes up at the top. There are these pop-up bumpers here. There are a number of targets that are triggered over here by when the ball hits them. There are down here, these are called sidekicks or slingshots. Basically they fire like that and send the ball flying from the corner. And there are flippers as associated here, which are handled by the switches on the outside that we'll talk about. There's also a small display module. We'll talk about that in a little bit later. And of course there is the ball system for firing the ball up. Oops, sorry. Like so. Okay. Talk about the rollover lanes first. Okay, when the ball goes through one of the lanes, basically it triggers a switch. There's a small switch here. Basically, when that's triggered, it sends information to our central processing unit, which then sends information to turn the light on. This is all handled digitally. The reason it's handled digitally is you notice that even though the switch is no longer activated, the light stays on. Also, I have control within the game to shut those on or off at any time. For example, once I've completed all three of the lights, I can have the program automatically shut them off. So that's why I want to be able to control the lights digitally. Next to that are the pop-up bumpers, and you can see that these are activated by a small pad down here that when that pad is the ball hits it, a piece of metal comes flying down, And when that comes flying down, it basically squeezes the ball out and sends it flying. So, like that. You notice it also lit up, which is also controlled by the central processing unit. The targets act very much like the switches that we showed before. Basically, once you press this far enough, it makes contact with two contacts back here, which are similar to what I use for the flippers. We'll show you those in more detail in a second. But once that does, again, it sends information to the central processor, which sends it back to, sends lighting information back to the light, and it lights up. The slingshots down here have a couple of switches on both sides, and basically what happens is when those are triggered, it causes this thing to fire forward, and that's what pushes the ball forward. What I'm showing you now is a little LCD screen that I use in order to display both the score and the ball count. When I fire a ball, you can see the ball number is recorded, and you can see that when points are scored, the values are displayed above it. Because I have this small little board, I don't need the big back on this machine, and that's why there is no back on it. Obviously, if I wanted to make this a multiplayer game or to control things like, display things like high scores and so on, I would obviously need a bigger screen somehow, and a back might be more appropriate to add. But for this particular game, for what I wanted to accomplish, this was sufficient. Okay, the ball handling system of this pinball machine is a lot more complicated than it looks. First off, there is the ball plunger or the ball shooter assembly. Basically, obviously, when you pull the spring back and fire it forward, you know, it fires the ball like you've always seen in other pinball machines. Be very careful when installing this. You want to make sure that you get this perfectly aligned with the where the playing field is. Otherwise, you could have trouble with it and not firing correctly. I also have a rollover switch up here. This helps me tally when I've actually shot a ball and therefore know when to increase the ball count. I also, as far as when the ball is lost, down here, very simple mechanism, kind you would find in a kid's game where it just basically gravity acts to send the ball over to this area. There is an opening here that allows you then to fire the next ball off. You'll also notice here there is a small pressure pad. This is a force sensor, and it again lets me know that the ball has been missed, so I can, for example, at the end say that the game is over and flash that on the display screen. One other thing I'd like to point out is these rails. For some reason I had a lot of trouble trying to find rails that I could buy to work on this kind of system. So what I did was I found in the home store some small metal chrome steel, just bent it into shape, drilled some small holes, and epoxied them in place, and these work very, very well as rails for guide rails. Okay. This is an example of a typical switch. It's the one that's being used to power the flippers. Basically, there are two contacts on each side, and there's some electrical contact areas in between. In this case, there's a button that's pushed on this side, and when that's pushed, it makes the things connect with each other, and you can hear the firing of the flipper when those two contacts get close enough to each other in order to complete the circuit. These circuits, like all the others that are actionable, they are run on the higher voltage, the 25-volt power supply. This is the pinball machine turned upside down so that you can see the individual components. What we have here are two bus bars. Basically, power is coming from a 25-volt power supply that is located down in the box itself. And basically it sends it to these so that we can distribute it to the higher voltage systems. You'll notice when you see all the wires here, there are two types of wires. There are the thicker wires, 16 gauge wires like these, which are used for the actionable components of the machine. Flippers, the sidekicks, the pop bumpers, things like that. That's because they need higher voltage and more power. You'll also notice some thinner wires, a lot of them up here, all of them leading to the central processing board, which we'll talk about in a little bit. But those are lower voltage, only about 5 volts generally going through those, and those are for things like turning on lights and switches and so on. So let's talk about the individual components. Let's talk about the flipper mechanism. In the flipper, what we have is that power is sent when you hit the switch into the solenoid. Now what the solenoid does is it creates a large magnetic field which causes this particular arm to retract. When it retracts, that motion of retraction is converted from linear motion into rotational motion through this mechanical connection, and that's what drives the flipper. The reason the solenoid is used is because of the very high speed at which they can function, as seen here. This is the pop-up mechanism. Basically, you notice there's a switch up top here that when it's triggered, it causes this solenoid to pull up on the metal ring that we talked about before. You'll also notice there's a small little board here that lights up when that happens. And basically what that is doing, you'll notice this board has on it much smaller gauge wire than the power going to here. It is used to send information to our central processing board that lets you know that the pop bumper has been hit. And the way it does that is, this is all 25 volt material. That's much too high in voltage for the central processor to handle. It needs 5 volts. So what I've done is I've installed a voltage divider here that basically lowers the voltage down to 5 volts. At that point, it then is suitable for handling by the input-output board of the output aspects of the central processing unit. This is an Arduino board. It is basically the brains of this system. Basically, it's got a central processing unit built into it. As you can see, there's a lot of different wires all leading to it. All of those are coming from things like switches, or they are going out to things like lights. The nice thing about this board is it's capable of sending both receiving information and acting on it, so getting information from switches, but it's also possible for it to send power out to things like the lights. So you get it to be able to both control the lights and to respond to the switches. There is a USB connection here. That allows me to program this board in order to respond the way we want and control the elements of the game. And there's also a small power supply that can be connected up here. That way when you want to run it, you don't need the power from the computer to run it. You can run it directly off its own power supply. And that's basically the main components of it. There are things in addition to those. There are things like lights and switches, but those are fairly obvious as to how those things kind of work. Well, that's about it. I hope you enjoyed this video, and if you do decide to build your own pinball machine, I wish you a lot of luck. I have included some links at the end of this video that you may find helpful with additional information. So goodbye and have a good day.